called Userpoint Technologies. Userpoint Technologies is a company based in Kenya. We are a POS company. We build the point of sale software that is, it's more of a software as a service. We are trying to beat the other POS in the market, since most of them are standalone applications. So it's a startup that has also received a lot of funding from Google, and several venture capitalists. So we are really moving very fast. We're supporting a client base of close to 1,200,000 customers. So our system is so complex. So we are supporting several businesses on that platform. And I joined the company as a DevOps engineer because we are transitioning to what we call microservices, which is one of my key areas of interest. So we were building the software upground from scratch all the way to production, since the original application was a monolithic application which could not stop the increasing number of customers who are using our platform. Maybe to talk about my background, I have a background in IT. I did a bachelor degree in computer science from Nyeri. So I did that back in Nyeri. Though I have a story even before getting into computer science. Computers for me was something that was so new to me. It's something that I got interest in after high school, just like any other kid. I was more of medicine, but I was cut short when COOPS placed me for a nursing program, and I felt nursing was not what I needed. So I shifted. I tried to figure out career change during the first year of university. The first semester, I learned nursing for one semester and then opted to computer science. So I had to take another semester back. And that's how I got to tech. So within computer science, it was moving all over several things. You are in pen testing, you are in machine learning, you are in data analytics. You are trying everything to just weigh out what best suits or what can be of interest to you. And I finally settled to what we call software development. I was introduced to a friend who was writing HTML files and launching them over the browsers, and was like, this is so good. Why can't I try this? And that's how I managed to venture in software development. So I was lucky enough to get an attachment in a software development company based in Nairobi called Eclectics. I got a 3 months in attachment, which was more of a learning curve for me. I was introduced to different tech stacks. I was able to understand to experience the real life scenarios of software development. So after 3 months, I was well to go, and I was absorbed as part of their team. So my main role in that company was I was placed in the backend development team, whereby we were building applications, the RESTful APIs using Spring Boot. I don't know whether you people are somebody who is familiar with Spring Boot. Spring Boot is a Java-based framework that is used to build backend services. So they were using different technologies, but I was placed in the Spring Boot group, and I was exposed to so many projects. Remember, it's an IT company that builds custom softwares. I am lucky to be part of the guys who are developing the RESTful APIs for the cooperative bank. I don't know whether you people you're using the COP. There's the new application or part of the team that were developing the RESTful APIs for that company. So that's one of my key achievements in that company. And then, while in that company, I was promoted to a position of product manager, tech product manager. Remember, we are handling several projects. I was placed to lead a group of developers who were building a software for a client based in Malaysia. It was an e-learning platform. And I was the product lead for some few months before I left the company for other green pastures. So that one introduced me to not only software development, but I was also able to engage to other activities of the whole cycle of software development, maybe meeting clients, representing the product to management and the operations team. And back then, I remember there was this client who had a very good, we were building a software application for him, and he had a very good DevOps team. So we used to work together with the DevOps team from his company. We, the developers from our company, and then we work with his DevOps team to streamline or to create that application. That's like, this is something that looks interesting to me. So from there, I started hovering around to see how I can get to DevOps, watched a lot of tutorials, videos, and lucky enough, I was accepted in one of the best boot camps. So for me, I got to DevOps through boot camps. I got an online bootcamp based in Toronto, Ontario, called Landmark Technologies. Landmark Technologies is a company that offers DevOps engineering services to other companies. They outsource, it takes DevOps, it offers DevOps services to other IT companies or even to other companies who want to streamline their software development lifecycle. So it also has that trainee program, which is more of a bootcamp, an accelerated bootcamp that takes you 4 months. With the literal knowledge that I had gained about continuous integration and continuous deployment while being part of Eclectics, gave me a lot of, made me to assimilate very well with the bootcamp experience. And one of the key factors that made me even to push hard within that bootcamp was we had guys who are doing pharmacy, others who are doing nursing, others from accounting background. And we are starting from scratch, learning CI/CD, monitoring, all that stuff, the cloud thing and all that. So that one gave me a head start. What the company does, once you go through there, you have to pay for the bootcamp. But once you are through with the bootcamp now, if you prove to be proficient enough, they will give you an opportunity to serve as one of their DevOps engineers. And that's how I got to work remotely for that company for a good number of years. I rose to position of site reliability engineering. Yeah, it was a nice experience. It exposed me to a lot of DevOps ecosystem, learning a lot of tools, working on different projects, maintaining applications and all that. But my keen interest within the DevOps ecosystem has been specifically in what we call infrastructure as a code. I have been more of writing the Terraform configuration files and provisioning the whole infrastructure for companies. That has been more of what I was really doing in that company, and doing the application performance monitoring as a site reliability engineer, writing the SLAs, SLOs, and SLAs. I know those who are familiar with the SRE technologies are able to understand those concepts. I will not go further on that. Now I had initially talked about the new company that I'm working for. We are building a cloud-based POS from scratch. We started early January, and we are close to completion. The system is close to completion. We are working very fast with a team of close to 15 developers and 3 DevOps engineers. So I take the lead as the man who leads the DevOps part. Although I'm also part of the development team, because we are doing them. The reason why I got to the tech lead, because I have that interest in microservices, how you integrate different applications to come up with a good system, a robust system. So that's more of me. I don't know whether I have talked so much, or maybe that's all. Back to you, to Angaze Tech Africa. Maybe can I share my screen now? We start, or any question? Oh, okay, let me share my screen. I don't know. Are you able to see my screen now? All right. Uh, Oh, let me. Wow. Just a minute. Uh, where is this WhatsApp thing? Let me share again. Let me share the whole screen, entire screen. Mhm. What about now? Are you able to see the first slide? All right. So I don't have a lot to talk about microservices. Just prepared a walkthrough that we going to take you through. So we're going to talk about microservices, my tech journey. I think I've talked about my tech journey. So let's begin. What are microservices? Maybe I need the session to be more of an interactive one. I need to understand from the audience what comes in your mind when you hear the word microservice. I know some of you are familiar with this word. What do you think microservices are? Need to hear from maybe a volunteer to just tell us what are microservices before we proceed. Anyone from the team? Or let me pick someone. Anybody with a clue what are microservices? I think Felix. Felix, do you have an idea what the word microservices? Have you ever come across such a word? What do you think microservices are?
Hello. I think this is breaking down an application into the various components that function together to operate.
Wow, that's nice. That's nice. Yeah. Thank you. Yeah. What he has just said is correct. So let me proceed. So this is a layman or a small or just a brief definition of microservices. Microservices are small chunks of a big application that has been developed, managed, and deployed independently. In most cases, when you're talking about microservices, you will hear about this concept called microservices architecture. People are talking about microservices architecture. What are microservice architecture? A microservice architecture involves breaking down a large application into small, loosely coupled applications. Yeah, that's what we call microservices architecture. Breaking down a huge application into small, independent applications that can be deployed separately and they're able to scale separately. Mhm. Then I have a small diagram. I know it's not that clear. I got a small picture that's talking about some history about microservices. Maybe I can just read. I know it's not that clear. So I just got an hierarchy here that shows the journey all the way from early 2000 to where we are, 2023, 2024. So the first, or the initially we had something called service-oriented architecture. And then that was early 2000s up to 2010. People were talking about an architecture called service-oriented architecture. And from my understanding, service-oriented architecture, I've never been exposed to this, but I know it's an architecture whereby you have a middleware whereby you are creating services that are reading from that one uh, middleware. For example, in a banking application, you could have one all the features that are similar to different applications are grouped together, and then you have small pieces that communicate or fetch the required logic from the middleware. It's a huge topic when we start talking about service-oriented architecture. I'm not even that concerned about it. So the concept of microservices was born or was first coined in 2011. That's when people began talking about microservices. You will read a story about a guy who wrote an article trying to talk about how you can break down a system. Once you're building a software system and it gets too large, how can you break it down without losing sense? There's a whole article about it. I'm going also to give a name about that. Then 2012, two companies got serious about this. One of them was Netflix and AWS. The two companies changed their architecture into what we call microservices now. Netflix is I think it sells movies, streams, and all that. It broke down its architecture into what we call microservices, and it gave a way for other companies now to see the benefits that come along with microservices. The two companies were the pioneers of microservices architecture. If you go online, you get a lot of stories about how Netflix implemented the microservices architecture. And then 2013, Google was here and came up with something we call Docker. I know you guys are doing DevOps, you know Docker. Docker. So Docker was so instrumental in microservices architecture or making the whole journey of microservices more easier. So we are going on also to learn how Docker works within the microservices architecture later on. So on 2012, another amazing tool was born called Kubernetes, K8 is Kubernetes. That was also so instrumental in propagating the journey of microservices. In 2017, 2019, there was so many articles or so many innovations within the microservices architecture. Like 2019, there was a concept that was so important called circuit breakers. We'll also talk about circuit breakers later on. That was key in the microservices. And in 2020, there was the concept of serverless architecture within the cloud computing environment, which is also important within the microservices architecture. I forgot to mention here that in 2017, Microsoft was also in the game. So looking at these features, you'll realize most of the tech giants were so keen to transition from their original architectures to what we call microservices. We have talked about Netflix, AWS, Google coming up with Docker. We have also Microsoft chipping in 2017 to build most of the applications using this architecture. And in 2021, tools like GraphQL, Apache Kafka, we are going to talk about Apache Kafka later on. This was also instrumental in the same journey. And in 2023, we have service mesh. We are going also to talk about service mesh architectures, which is also a very key concept within microservices. So that's a brief overview about the history. I'm not going to focus more on that. Let me go down. And before we talked about the service mesh, or before we talk about microservices, I'm going to mention about this architecture, which has been dominant in market for long, which is called monolithic architecture. Monolith architecture is an architecture whereby we have the whole application code base existing as one unit. Giving an example of this, if you're building an e-commerce application, it has several functionalities, but all these functionalities are bundled together in one application. For example, we can have a functionality to perform cart, checkout, to add products, people to sign in, to sign out, maybe to all those functionalities being bundled together into one application is what we call monolithic application. And in most cases, you'll also find companies that are building both front end and back end together using some of frameworks like Laravel and Django. So that's what we call monolithic application. A situation whereby you find the whole software application or the whole software application is bundled into one unit. That is monolithic, and it has been dominant in the market for long. But nowadays we can see the trend. People are talking about microservices. Several companies are running to microservices. So this is a general breakdown of a microservices architecture for the same application that we have seen above there. So we have a client, that is my front end, and we have some arrows there showing traffic in, traffic out, and then we have our application now, which has been broken down into individual services or individual applications. We have authentication service, that will be an application by its own. We have another service, which will also be an application by itself. We have a catalog service, which will also be an application existing alone, and a service B, and several. You can have as many services as you can, depending on the business functionalities of your software. And then we have a database. We have each service having its own database. You can also have one database that all the services are fetching or fetching data from. And then I can see something to do with AKS there. So these services are deployed in a cluster, in a Kubernetes cluster. Just an overview. And then we have another diagram here. Confirm whether you can see it well. I think this is better than the other one. We have client apps, web. For example, I assume this is my front end. And we have a mobile application, which is also consuming APIs from the services that you have built. And then I have several services: catalog, shopping, discount, ordering, and each is connected to its DB. So this is what we call microservices, breaking down a huge application into small individual applications that can be deployed independently, and they are able to work without being disrupted by the other applications in the same domain. Up to that point, any question? Or maybe before you ask question, I could have talked about an API gateway. So what happens in microservices? Once you break down your application into several services, one of the key things is communication. So the services communicate to each other using something called service mesh, and they also, like the web and the mobile, are communicating with the services via what we call API gateway, which is just it's more of let me just call it a storage, whereby you just register your RESTful APIs from different services so that they can be consumed by our front end. So API gateway is one of the key factors within microservices that is quite important. It is the one that will facilitate clear communication between your microservices and the client hubs. It's not a mandatory to have an API gateway, but in most cases, once you have a very huge application with several microservices, having an API gateway will serve a better purpose. So we have a DB for each microservice. Something else that I can also add here, though we are going down there to advantages and disadvantages of microservices. But before I proceed, I need maybe somebody who has some question or maybe something that you want us to clarify. You may ask before I proceed. Any question? Go. Yes, Mustafa. Go on.
Yes, morning, Steve.
Yes, morning.
Yeah, my question is, before microservices, what were we using?
So in most cases, before microservices, we have what you call monolithic architecture. But I will not. There are two instances of a monolithic architecture. We have a monolithic architecture which involves the backend and the front end being combined together you just create the front end and the back end together in one repository, or what will I call it? People who have built applications using Django. Django comes with a template thing to where you can specify the views. I've seen the same with Ravel, Spring Boot. We have a way you can inject views within your application. That is one instance of a monolithic application that was being used, but with the time people shifted to another advanced, I would call it a more advanced concept within monolithic architecture called three-tier architecture, whereby you have separation between the front end and the back end. You are able to build the front end using React, Angular, and then the back end using something like Ruby, Django, and all that. But that one was still part of monolithic architecture because you have just a whole application bundled in together. You will have the whole backend bundled in one thing. So that's the concept that people are mainly using nowadays is three-tier architecture, which is part of monolithic architecture. That's what I will. That's it, Mustafa. I don't know whether I was clear enough or.
Yeah, you have been clear. Maybe I will go and do more research about it for clarity.
Okay. So this is the monolithic architecture. In fact, this is a monolithic architecture, the advanced monolithic architecture, whereby we call it three-tier architecture. Three-tier architecture is where we are separating. We have a client user here. This is where you will write your front-end application either using React, Angular, Vue, and all that. And then you have your backend, which is just a wholesome application where you're going to write your backend logic in just one code base. So maybe to just elaborate a bit, when you're talking about microservices, you will have less interest in front end. In most cases, the reason why we are breaking an application into smaller applications, you want to make it as lightweight as you can. So in most cases, we are going to focus on the backend aspect of everything. When you have the backend being a wholesome code base, without it being broken, that is monolithic. Regardless of whether you have the client within it or you have it outside, it will still be monolithic. And this is the architecture that most companies are using. Like the company that I'm really working for, we were in this concept. We had a front end that is well existing alone deployed, and then we have our backend also, which is just one code base, a very huge Ravel application. So that's monolithic, and that's the application that most companies are using. So I can proceed now. If anybody else with a question?
Hi, Steve.
I too.
Okay. So one question.
Yes.
Maybe you can go back to that diagram where we have the API gateway and the microservices. Yeah,
this one. Yes.
So where does the ingress comes in here? Or does the API gateway has the capability of doing or exposing the services to the outside from the cluster?
Okay. You had mentioned something to do with ingress.
Yes.
Okay. So what happens? Let me talk about ingress just a minute. I will not put ingress at this point. Ingress will assist in exposing each service to the internet. Yes, ingress is an example of what we call an API gateway. Ingress is an example of what we call an API gateway. That is one of the API gateways that we call it ingress controller. Nginx ingress controller is one of the API gateways that is quite in demand in the market. And we have others, but that one is the most common. So what it does, we know ingress, the purpose of having ingress is to ensure all the routes that are coming from these services are exposed to the internet. Now, that's why we have the other client apps being able to fetch all that and consume them. I don't know whether I've answered you or
Exactly.
maybe.
Yeah. Sure. You have
Okay.
answered my question. Thanks.
Okay.
Okay.
Any other question before we proceed to the advantages and disadvantages? Yes.
Yes. Like I wanted just to get a clarification where he was explaining about the monolithic. So is it kind of a Django or maybe web application whereby we have like we have the Django is for the backend and we have different like templates. So it's kind of a one, like it's a combination of both backend and the front end. Is it that way? If I
Ye-
may.
Yes, Dorothy. Thank you for the question. So I had said we have two types of monolithic applications, or we have two types of monolithic architecture. One is like the one that you mentioned. We have Django being the everything. You can have the whole application being built in Django. Django will come with a template in engine for you to write the views and all that. That is
Yeah.
one. And due to complexity of making an application, the code base to be large, the new concept of 3-tier architecture came in, whereby you are separating now the front end from the back end, but you are not breaking anything. That's where people lose direction and think that is part of microservices. You are just separating the two, the front end and the back end, but you are still within the monolithic aspect. Yeah.
Okay. Thank you for the clarification.
Okay. Any other question? So we can proceed to the advantages. Let's see why is it that Microsoft, Google, not really Google, Netflix, AWS, that is Amazon, choose to, or why are several companies running to microservices architecture? We want to see the advantages and disadvantages. So let's start with the advantages. One of the advantages of microservices architecture is scalability. What do I mean by scalability? Individual services scale independently based on their specific demand. For an instance, the CAT service can be scaled during high traffic periods without affecting other services. So before I even explain this concept, one of the when we were talking about the history of monolithic, no, the history of microservices, we mentioned a tool called Kubernetes somewhere, which is one of the tools that DevOps engineers are currently learning a lot. What Kubernetes does, it enables you it enables all the applications that you have deployed to auto-scale, auto-scaling means increasing when demands increases, and it also goes back when the demand is not that high. So being in a microservices architecture, scalability now becomes easier because now you are only going to scale the specific service that has been demanded. Assuming a scenario whereby I've deployed a monolithic application to the Kubernetes now, and I have also deployed another application which is in microservices, the same stuff. The demand can be in one, a very small functionality can be the one that is needed, that its demand has increased. So being in a monolithic architecture, it will scale up and maybe consume a lot of or maybe take time even what will I say? But once you have broken your application into small instances, the only service that is being the one that its demand has increased is the one that is going to auto scale. That one maybe to bring what we call the scalability concept. Then we have resilient. As we know, if you have now broken down your application in small checked, if one of the services fails, it will not impact the system. For example, when the card service fails, it will not impact maybe product service. If you are going to debug, you're not going to take a lot of time trying to work on the other services. You'll just go to that specific instance that has failed. Remember, we talked about they are deployed independently, so they are existing by themselves. They only communicate to share information among themselves, but when it comes to being developed, being deployed, they are just independent. So resilient. If one service fails, the rest are okay. They will not an entire system. Unlike a scenario where we have one system, once like a small something happens in the catalog, you have to go back to the old system to look at the configuration issues and all that. So another concept that is very, very important is talent diversity. What do I mean by talent diversity? One of the biggest things about microservices is that these microservices can be developed in different programming languages. For example, when we are building this e-commerce application, we may choose to build the catalog microservice using Golang. We may choose to go for discount microservice using PHP. We may go for shopping cart using Python, all that. But it will not have an impact in our application, in our system. So that one makes us to better utilize our team, or you're able to assign developers to work based on their tech stack. I know some of you, I don't know whether it's me or I've faced this. You get to a company, you find they're using Laravel, you've never touched Laravel. You find to another company, they want you to study Ruby. You go to another company. If you are adopting microservices, if you bring somebody who's good in Ruby, you work on that microservice alone. And another guy who is good in Node, you work on that microservice that is built in Node. So you're able to use someone's best talent or what he's good in, other than forcing them to start learning a new technology and all that. That is one of the key concerns that these companies benefit from when they adopt microservice. Talent diversity, you're able to make sure developers use their tech stack. That's a very key concept. For example, I can give an instance. In my company, we are building some of the microservices using Spring Boot and others Golang and Node. We ran away from Laravel. It was initially a Laravel application, but now we are using Golang, Spring Boot, and Node, the Express.js. The other advantage is easier maintenance. Just like Resilient, you are able to maintain since if one system or one component goes down, you're able to handle that independently without having to go to the whole system and check in what and all that. Easier maintenance, quick deployment time. You can build one. Okay, what do I mean by quick deployment time? Remember, we talked about talent diversity. You bring guys who are going to work on one microservice while the other team is working on the other microservice, and the other team is working on other microservices. So at the end of the day, you just have the whole system working. The guys who are developing using Python, they don't want to think to be concerned about the other guys who are building using Golang. As long as they're going to build the application and it's running seamlessly, that's okay. So it makes the time that you're going to take to deploy that software quite easier, quite fast than when it is a whole one thing. So let me talk about another advantage, which is microservices are compatible with Docker, Kubernetes, and cloud technologies. If you look at the new technologies that have been coming up, they have been developed with interest in supporting microservices. Talk about Docker. Talk about Kubernetes. Docker is the platform that enables us to build containers. And then Kubernetes helps us to orchestrate those containers. Remember, what we mean by orchestrating is bringing several containers into one, or you're able to manage them. So if you're building an application in microservices, you have several instances of the same application, several services. So with Kubernetes, it enables you to orchestrate those Docker images for what? For the same application. Looking at the cloud services, There are several services that have been also geared toward this. You can talk about load balancing in AWS. We have image registries. I think every cloud provider has these concepts. These services are more geared to support microservices architecture. You're able now to work on an application that is independent without having it, or you have it in isolation. The another advantage is what you call, it supports two-pizza development team. So what do you mean by two-pizza? I know this is quite interesting. Jeff Bezos, the CEO of Amazon, came up with this rule. Remember we talked about AWS or Amazon being one of the first company with Netflix to adopt microservices. He came up with this rule. The development team should be small in such that each can be fed with 2 pizzas. I don't know whether you find it amazing that you have a development team that you can just feed them with 2 pizzas. So like in real life scenarios, you find when you're building an application in monolithic architecture, we have so many developers. You have close to 30 developers working on the same application. When I'm talking about an enterprise level software, you find 30 developers working on the same application. So many issues arising on the way. So at that point, you cannot feed that team with 1 pizza, with 2 pizzas. So by a 2 pizza rule, Jeff Bezos wanted to mean that in his team, he wanted to break the application into smaller instances such that a very small group of developers can work on one service. They are responsible for that service. When it goes down, they are the one who should be asked, and they are the one who are going to maintain it, while another team is working on the other service. So that's a very good and a very good concept within a company that is going to adopt microservices. We'll have responsibility being assigned to the respective person. If you have 2 guys who are working on that service, if anything happens, they're the one who are responsible, other than having a whole team. You don't know who changed what and all that. So let me go to the disadvantages of microservices. Disadvantage number 1 is increased complexity. When we move to microservices, a lot of complexity is going to be witnessed. You'll have so many. Assume you're building an application with 10 microservices or 15. You will face a lot of integrations underway. You need to know which microservice is doing this and which is doing this and all that, and try to figure out communication between one microservice and the other, and even be able to come with the relationship between how will this microservice be able to communicate with these and how are they exchanging data. Data management challenge. Remember we talked about databases. That's the main challenge now. We are having one database, or we are building an application that has been broken down into several applications, which has writing and reading database concurrently. So at some point you can have order service fetching wrong information since the order service had changed, or the card service and changed the database where the order picked a different details. You end up printing wrong receipts and all that. So data management is a challenge. And another one is increased computing cost. Remember now you are going to deploy several applications. We talked about them being deployed in isolation or independently. Assuming now you're going to deploy on a VM, let us not talk about Kubernetes. You're going to deploy them on a virtual machine, EC2 instance. So how many EC2 instances are you going to create for deploying 10 microservices? So you may end up having 10 instances. That is an increased computing cost as to compared to when you had one monolithic architecture. So that is the advantages and disadvantages. We have several. If you go to internet, you get a lot of them and others, but I choose to focus on a few. I also wanted to talk about microservices best practices. So one of the important things once doing microservices, you are expected to use version control. And within version control, I'm going to talk about 2 key concepts we call monorepo and polyrepo. By monorepo, I mean you are building an application that has been broken down into 10 microservices, how are you going to organize them within the version control? For example, Git. So you can have a monorepo, one repo for the whole microservices, or you can have separate repositories or separate repositories for each microservice, and each comes with its own advantage and disadvantages. But in most cases, what I've seen and the trend that I've witnessed, people are going for monorepo. Monorepo is quite easier. In Git, we have something called folders. You can have folders for each of, or you create a directory for each of the microservices, but ensure you are able to follow the right path while running each instance. In most cases, like in my company, we are working on one repository other than going for polyrepo. It's easier to have monorepo since we are also going to talk about the DevOps ecosystem within the microservices. Remember, now if you are going to deploy 10 microservices, you will have continuous integration and continuous deployment for each microservice, all the way from when the code is pushed to GitHub or up to when it is deployed. So if you are going to opt for polyrepo, that one can somehow tend to be tedious, though it also makes your work clean. But having a monorepo, you are able to write another folder, or you're able to create a folder for shared services. If you go for monorepo, you can have some files which are shared among, or you can have a values file that you are going to insert values that are going to change dynamically for deployment purposes when it comes to Kubernetes manifest file and all that. So monorepo comes with several advantages. I'm not going to tackle that, but that's an area that you are also expected to expound as you choose to focus on microservices. And then another best practice is implement continuous integration and continuous deployment. Very key. Remember, now you are working on 10 microservices or 10 applications. So if you are going to work on the manual way, you are going to perform unit testing, you are going to perform integration testing manually, it's going to take you time for you to deploy this software. You creating an artifact and then you go fetch it, you build it, and then you go manually deploy it on a cluster. All that will take you time to deploy this. So one of the best practices, ensure you implement very robust and clean continuous integration, continuous deployment pipelines for your application. That one will make it easier to perform testing very fast. Let me maybe to expound a bit about how you're going to do this. In my company, we are using Jenkins, and the way we go about this, we create what we call multi-branch. We have multi-branch pipeline within Jenkins. That one enables you to perform CI/CD very fast. So you make sure every microservice has its own development or one branch for each microservice, and that is the branch that is going to be read by our Jenkins server. So we will have several pipelines running concurrently when something is changed within the source code. So multi-branch concept within Jenkins comes handy when we talk about continuous integration and continuous deployment in the microservices best practices. I know guys have a lot of questions. Maybe before I talk about the next concept, I wanted to go forward and talk about how communication happens within one microservice to another. If you want order service and catalog service to communicate with each other, how is this? How does this happen? So I wanted to mention a bit about that. Before I proceed, any other question? Anybody with a question? I can see Mohammed. Yes, Mohammed, how are you?
I'm fine, Steve. How are you doing?
I'm doing good, bro.
In this point, I would like you to explain for us the difference between the microservice engineers and the integration engineers.
Oh, I talk about the microservices engineer. Yeah, that's a new concept by the way that is coming up. I see guys who get that title, microservices engineer and the integration engineer. So For me, I feel integration is more of a senior level developer who knows how to write RESTful APIs, who works best with the APIs. He is more of ensuring that once he works closely with the developers to ensure anything that is needed within a catalog service. For example, within catalog service, we might need an M-Pesa integration, we need PayPal. That's the work of an integration engineer. He'll work on that bit. We want to integrate e-teams, we want to integrate what? That's the guy who work on those integrations. He works with the APIs. You get external APIs from vendors and then integrate them within that service. Remember, each service will have other functionality. Maybe it can be a catalog service, that checkout service that wants to integrate with PayPal, any other, all that. He is more of a developer who is more knowledgeable about integrating your application with external APIs. And then we have the microservices engineer who ensures that the RESTful APIs that are coming from each microservices are well, let me use the one placed, or are well documented within the API gateway that I showed above there. And he is also the man who handles, or he is the person who also handles the service to service communication. He ensures that catalog and order service are always communicating, such that once something changes within the order service, catalog is updated of that change. Yes. Okay, any other question?
Steve, I have a question.
Yes.
Okay, so I want to know from your experience, do you have an approach when it comes to choosing the best CI/CD tool? For example, where I work, we usually use Tekton as the CI tool and Argo CD as the CD tool. So, like from your experience, do you have a best approach of choosing the best CI/CD tool?
Okay. Yeah, I know Tekton. Tekton is from GCP, something of such sort.
Yes.
Yeah, I've heard about it. I've never used Tekton at any. So when it comes to CI/CD, it will depend. In most cases, you find a company with an established way of doing things. That's one of the key things that I've encountered. Like when I was working in Landmark Technologies, Jenkins was key. And we have other projects that we are using GitLab. GitLab also has a very easier way to write CI/CD pipelines. So for me, I feel it depends with the company having its own way of doing things. And then you also get to a point now where you're left to make decisions. So when you're left to make decisions now, one of the key factors that I'm going to focus on is documentation. Some of these tools you can have Tekton, but once you encounter a challenge within it now, the community that is around to assist you when you face a bug is key. So like when it comes to Jenkins has a wider community that you can we have a Slack channel, a whole Slack channel with thousands and thousands of developers. If you encounter a bug there, you just raise there and in a minute you get support. So for me, I look as a popular tool that I can get support, and also chances for maybe when the complexity or when the number of pipelines that I want increases. For an instance, now I'm building 10 pipelines. If you go to GitLab, that one can be a challenge now. You running concurrently 10 pipelines at the same time. You remember, we want, if anything changes within our code base, the 10 pipelines to run seamlessly to ensure that our local environment and the production environment are well. So you find if the number of applications that you're going to deploy increases, you might look for a tool that will enable you to be able to write CI/CD pipelines that can run currently. I talked about the multi-branch strategy within the Jenkins server. That one comes very handy. Yeah. So for me, if I were to work on the 10 microservices using GitLab or using Tekton, I'm not sure whether that is still there. I may end up writing, having to run one CI/CD pipeline at a time. And I want them to be concurrent so that everything is updated. Every time a change is made within the catalog service, everything within my production is updated. Yes.
Oh, okay, thanks.
Any other question? Okay. If no any other question, I will just now finish up with something called service mesh. Service mesh is a network infrastructure layer that allows various components in distributed systems to communicate. Let me not use a lot of language that is used here. A service mesh is the last concept that we saw in the history of microservices. Remember, I talked about one of the biggest challenges. We have complexities in terms of communication between several services that you have built. So service mesh enables you now to make it easier. Other than even communicating via the API gateway, you can have another way to enable your services to communicate. If catalog service wants to talk to shopping cart, it doesn't have to go all the way to the API to fetch the word and what. With service mesh, you are able to list there's something called service discovery and service registry. Once you build a service, you can register it, and it is also discovered by the rest services. That one makes it more easier to communicate between the two services. For example, I've talked about catalog and discount. If discount changes something within my DB, we need catalog to be updated with the same information. If you're going to go the API gateway way, this might take some time, but we want this one to be very fast. So we have something called service mesh, which came around 2023 or 2020s. Service mesh now enables us to have a way to register and discover our services. Once you create a service, it is registered and then it is discovered at the same time by the other. So you're able to list your applications and they're able to understand each other, so that if one changes, the other one is updated with the change. For example, if discount wants to fetch the latest change within the DB that has been changed by catalog, it will just use the service mesh to question, has anything changed within catalog? Yes. So take the latest changes and retrieve the same data. So that's what we call the service mesh. It came around, the concept that came later when things got very hard in the microservices journey, and companies were using several other things. And one of the capabilities that come with service mesh is also replacing the concept of API gateway. Some of these service mesh platforms comes borrowed in a way that they can even perform the work that is done by an API gateway. They serve as both a service mesh as a service gateway for traffic management and all that, load balancing, security, and all that. Remember, we know load balancing and security is the stuff that was done by our API gateway. But now service mesh comes inbuilt with all that tools. And one of the biggest, or one of the tools that is currently in market is called Istio. Istio is an open source service mesh platform that allows us to set up a networking infrastructure for microservices. This one is better than Ingress controller. It comes with robust and security features inbuilt with it. This is the one that we are using in my company to ensure our services are registered and discovered by the other services for easier communication. Maybe to talk about other tools, but there's something that I never hadn't here. I just mentioned about it. There are several ways that services can communicate to each other. You can have the concept of service mesh, and we have another concept called message brokers. We have message brokers, which is also very important when it comes to which is also key. I see companies that are embracing these, but it comes with additional complexity because you have to do a lot of administration work and a lot of installations and a lot of integrations. So I will not talk about message brokers, but I'll give an example of one called Apache Kafka. That is one of the message brokers. That one replaces the concept of service mesh. Other tools we have talked about: GitHub, API Gateway, Service Mesh, Cloud Technologies, GCP, Azure, all that. And that's the end of my presentation now. Maybe I expect a lot of questions, comments. Yes, let's start with Ian. Ian.
Hi, Steven.
Hi too.
That was a good presentation. I have a question. In the Istio, which enables communication in microservices in a cluster, how do they go about that? Do they use the IPs and ports? Because I've worked with a project where now the microservices in a cluster are able to communicate through the IP, because if you have a pod, it will have an IP and maybe a port. So also, do you have to? So is Istio a third-party software that you have to install when maybe writing your Kubernetes charts, or kindly help me understand there.
Okay. A nice question. So let me just, for the purposes of the rest, and let me mention about the deployment process for the services. So in the Kubernetes, we are going to deploy our services in something called pods, and the pods will now be composed of our service, which has been deployed as an image, a container that is running, a running container. Okay, we have an instance of the application running in the pod. So there's something called sidecar. Within each pod we'll have what you call, now that's where we install the Istio. Istio is an open source tool that you're going to install within your cluster now. And every time a pod is created within it, a sidecar for within each pod will be created, and they communicate using proxies and all that. We have a documentation about, so it's a third-party tool that you must install within your cluster now. And it is able to integrate every time a pod is created. It is the one now that is going to perform the registry and the discovery process of. Yes. I hope, did I make sense? Ian?
Yeah, you did. Thank you.
Okay.
Yeah, you did. Thank you.
Okay, fine. Any other question? Maybe up to that, I will add over to Irene to tell us what's next now.
Hi, Erin. First, Steve, thank you so much. And I will have recommend you guys to have a WhatsApp group so that we can easily get the link.
Yeah, just for me, it's just to thank Stephen for the wonderful session, very insightful, and also helps some of us identify gaps where we can improve on.
Yes. First, thank you for organizing this session. Also, I have an article on just simple article on microservices. Maybe I can just share in the chat for someone maybe who wants to do a simple project on microservices. You can follow the article.